Okay, taking some important points for the combination formula. Okay, this formula for NCR is also used in binomial theorem. Okay, and it also find uses in many places. So to calculate the values of NCR more quicker, some rules have been formed so that the process of calculation becomes easier and we may calculate the value very quickly. Okay, so the first important point is this, that NCN is equal to 1. So NCN, which is equal to n factorial upon n minus n factorial into n factorial, is equal to 1. This means that if we have n objects and all the objects are selected, that is, the total number of ways of selection of n objects out of the total n object is equal to 1. So that is why 10C10, 20C20, etc. all are equal to 1. Okay. Similarly, NC0, NC0. NC0 is equal to n factorial upon n minus 0 factorial into 0 factorial, 1 upon 0 factorial equal to 1. So this means that the number of ways of that if we have total n objects and we have selected 0 objects, so number of ways of selecting 0 objects from the total of n objects is equal to 1. So this is also a way of selecting no object from the total of n object is also one of the selection. This is a important conceptual point. Okay, so this has to be kept in mind, that if we are not selecting any object from the total of n object, it is also one of the combination. Okay, so 10C0, 10 will be equal to 100C0. Okay, in that case any number here 0 is equal to 1. Okay, now NCn minus R, the basic formula is this, NCn minus R is equal to NCR. Okay, and its use is like this: if we have 5C3, then its value will be same as 5C, 5 minus 3, that is equal to 5C2. So 5C3 is equal to 5C2. Okay, so NCn minus R, it has the same value as equal to NCR, and we can prove it also. NCn minus R on applying the formula is equal to n factorial upon n minus R factorial into n minus R factorial. So this becomes R factorial, and this n minus R remains as it is. So which is equivalent to n minus R factorial, and this is its use. So if we by the way calculate the value of 5C3, then we need not have to calculate the value of 5C2, because 5C3 and 5C2 are both one and the same thing. And this also means the selection of R objects out of n objects, the number of ways of selecting R objects out of n object is same as rejecting n minus R objects. Okay. Next point, NCx is equal to NCy, then this means that x is equal to y or x plus y is equal to n. So first result, this x is equal to y is very obvious. If NCx is equal to NCy, then x will obviously be equal to y, no problem about that. And this also means that x plus y is equal to n. How? If NCx is equal to NCy, then NCx can be written as NCn minus x, and this will be equal to how much? NCy. Now since n minus x is equal to y, so n minus x is equal to y, or n is equal to x plus y. Okay, so these two results should be kept in mind. If NCx is equal to NCy, it is very rarely used, but whenever it is used, it makes the problem very simple. You won't have to expand these combination NCx and NCy to solve it. You can directly write the result. This is the advantage of this result. Okay. Okay, now we are going to take this theorem. NCR plus NCR minus 1 is equal to n plus 1 CR. Okay, so this result is the theorem of combination, and this states that, and it is used like this actually, that if we have 10C9 and 10C8, this is given to us. Okay, then this can be straight away written as 11C9. Okay, so instead of calculating this value and this value, this will be equal to 11C9 directly. Okay. Now, to prove this, I am going to, first of all, its proof is firstly very simple. I am going to expand these, both NCR and NCn minus R minus 1. So I am going to get this as n factorial upon n minus r factorial into r factorial plus n factorial upon n minus r plus 1 factorial into r minus 1 factorial. Okay. So I am going to take n factorial as common from here, n minus r factorial common from these two terms, and r minus 1 factorial common from these two terms. Okay, no problem about that. So I am going to get 1 upon r plus 1 upon n minus r plus 1. Okay, on taking LCM, this is going to give me n plus 1 upon r into n minus r plus 1. Okay, this r is going to multiply with r minus 1, and n minus r plus 1 is the next number after n minus r. So they are going to multiply and give me these terms, and this n factorial and n plus 1 factorial is going, n factorial and n plus 1 is going to give me n plus 1 factorial. This will be equal to n minus r plus 1 factorial and r factorial. So n plus 1 factorial remains as it is. This can be written as n plus 1 minus r factorial, okay, and plus into r factorial. So this will be equal to n plus 1 CR. So this is how we have proved this result. Okay.